Hello everybody, this is Mike of Backwards Machining. I wanted to do a quick, well, not so much quick, but I wanted to do a video on basically CNC, a very basic beginner video. So if you know anything about CNC and components of CNC, this video is probably going to bore you. So that said, let's get started. To do any kind of motion control or CNC, you need 4 components. You need, this right here is the breakout board, aka controller board. These are drivers, stepper drivers, for driving steppers. Okay. Forget the capacitor, forget the terminal block, forget the power, this power supply. So we have controller board, stepper driver, and power supply. So there are 3 components. This is a 24 volt, 16.5 amp, 400 watt power supply. Now, it feeds in, comes in here, splits off here, but essentially it goes to the stepper drivers. If you were to look on the side of the stepper driver, that's not upside down by the way, you would see some specifications. 9 through 40 volts DC, so we know that's 24, so we're good. You've got your high voltage part, which is, this is where voltage goes in for your power supply. This is for your stepper motors, A minus, A positive, B minus, B positive, and this is for your signal. Now, in here, this is how my box looks. So you have the power wires going in parallel to all the stepper drivers. Now, where you have the motor output, which is A and B positive negative, mine is running to an aircraft connector, a 4-pin aircraft connector on the back. Now all that for is to plug in my stepper motor. I usually wire up a 4-pin, the other mating part of the connector. Just, to me it makes it simpler, but you don't need to do that. You can actually take the wires straight off the stepper and put them in. You don't have to get fancy. And then once you have your stepper motor wires situated, you have to work on your signal wires. Now, that comes off of your controller board. You have X, Y, Z, and A on this board. Every board's going to be a little different, but you know, some will be a 3-axis, some will be a 5-6 axis, but generally you're still going to have your pulse and your direction and your axis. So on here, again, I'm going to turn this around for visual, you have pulse, direction, and enable. Forget enable. Enable is something we're not going to go over. That all that is when you tie that in, when you're not using the stepper motor, it shuts off the stepper motor. It shuts off current going to the stepper motor, basically keeping the stepper motor cool, which is great, but not in every situation, because you know, if you're working on a CNC machine, you don't want power cut off to your stepper motor because you're going to lose position. which is why I don't tie them up. So I tie all of the negatives together. Pulse negative, direction negative are all the white wires. They're all in parallel, and over here they go together. So every one of these wires, white wires, is all tied in together. Now these wires, the blue and the yellow, these are positive. So X pulse positive, X direction positive. That's your plus 5 volts. That's what sends the signal to the stepper motor, which in turn gives you motion. You tell it, move an inch, it sends as many pulses as it needs to move an inch. That's its job. So each one of these sends out the positive signal to each driver for each motor. Now, I showed you the 3 components. The breakout board, aka controller board, stepper driver, and power supply. Now there's one more obvious component that you're going to need, and that's the stepper motor. So why don't we look at a couple of examples. Alright, here we have NEMA 17 stepper motor. Now what NEMA signifies is the physical size of the motor. NEMA 17, NEMA 23, NEMA 34. There are smaller and there are bigger. Again, this is just, a reference type of thing that I'm trying to show you. So if you look at an application, and let's say you have a printer. So you see that you don't have a lot of room for a motor back there. So your application, you're going to need probably a NEMA 17 motor. So your next thing you're going to want to try to figure out is how much torque do you need. Once you know the physical dimension of the motor, then you need to figure out how much power you need to get out of that motor. And if you can look at that motor back there, you see the black thickness? See how this one's thicker? That's how the torque specifications change on these NEMA motors. It's the same size, but as you need more torque, these get thicker, longer, whatever. They just get bigger this way, not size-wise this way, because it's always the same mount. You use the same mounting size. It's the same with all of these. This is a NEMA 34. They come much shorter. Again, it all depends on, hold on, focus. It all depends on the amount of torque. Now, that being said, if you have a small area where you're trying to get a stepper motor into and you need a lot of torque, they also make what's called planetary transmissions for these. Let me see if I can find something here. Okay. Basically, you're looking at a NEMA 17 stepper motor, but it has a planetary gearbox on it, which obviously is going to slow your motor down even more, but it's going to give you all that much more torque. Now, stepper motors are not designed for speed. They are designed specifically for torque. So, adding more torque, getting less speed, you would have to decide if that's, going to be okay for your situation, or if you need to try to somehow finagle to the next size up stepper motor. And, you know, again, adjust from there accordingly. So those are your 4 components that you need. Your controller, stepper driver, power supply, and stepper motor. I mean, other than a computer, which I'm pretty sure goes without saying, that's it. And you have yourself automated motion. Now, there are different things you can get depending what you want to spend. Now this right here I got with this motor here. This is a hybrid stepper motor, and basically it just means that it's more towards a servo system than a stepper system. It's a more accurate type of system. Not necessarily needed in a lot of applications, but for one of the projects I'm working on, it's something I'm going to try for. Each one of these has a specification on it. This driver is 20 volts through 50. This one is 24 through 100. So you can start to see how this is getting, you know, it's going higher and higher as far as what you need and how much you're going to need. When you start to get away from the NEMA 23 and start to go into the NEMA 34, 42, I believe is the one above that, you have to get heavier duty control or stepper drivers. And though they're not expensive, I mean, they're more expensive than the smaller counterparts, but you start to run into power supply issues. Whereas each one of these generally requires its own power supply. So again, this is a little more advanced than I was trying to get for a first video, but just food for thought. When you start to get into the bigger sizes, heavier duty stuff, it's a little more complicated than what I'm talking about when I'm showing you that control box over there with everything in it, running motors like this. Now, as far as CNC controllers go, there's different types as well. This is parallel port style. These are probably $5, $6, and if you have a computer that still has a parallel port, it's great. These things are rock solid and very rarely give you any lip. If you don't, you can sometimes get a parallel port adapter, like a PCI card with a parallel port adapter. And, you know, if you can't or you don't want to, they do make these USB breakout boards. They just plug right into your USB and you're done. And generally these come with Mach 3, the software, so you don't even have to worry about it. This is actually one of the first control boards I got. I don't even know how long. I want to say 15, 16 years ago. I just wanted to show you guys this thing. This is how far they've come with technology. From this to this. Anyway. This is an Arduino. And these are stepper motor drivers. So each one of these purple things with a heatsink is one of these. So this is a 4-axis stepper motor driver on top of an Arduino. And if you go this way, you can use, I think it's GRBL is the stepper motor software. and it's free. So again, super cheap. You can usually get the Arduino, this board, the stepper drivers for under 20 bucks. I mean, you really can't beat it. And you can control smaller motors with this. Wow. Be it the 17 or 23. I've controlled both with no problems. This is a Raspberry Pi. No, not an actual Pi. I wish, but I'm gonna do some more messing around with this. I haven't. I wanted to make an isolated visual LCD control box that was a standalone computer, and I was going to use this to do it, but I just never got around to it. So let me show you the motors that I'm getting for my project. Alright, these are NEMA 23 dual shaft 570 ounce stepper motors. So they're this size, much longer, and they're capable of 570 ounces of torque, which is very respectable. So as far as figuring out what you need for torque for your project, that's something you're gonna have to try to work on. These motors are extremely torquey. I don't know if there's an easy way to do it. I know there's a mathematical way to figure it out, but I can't help you with that one. I'm guessing, you know, if you can turn whatever it is you're trying to automate by hand, you know, pretty effortlessly, then, you know, you don't need a super powerful motor. This would probably be an overkill. But at the same time, if you're going to be having high cutting forces, this isn't going to work either. So my best advice to you is to get the biggest stepper motor you can for your budget, because that's ultimately, you know, what this boils down to, is what you can afford and getting the best for your buck. That's basically what I'm trying to do with my projects. I've got so many different projects going on, I kind of have to limit what I can spend on each one, otherwise obviously I want to be going bankrupt. So that would be my advice, you know, to you guys. Just figure out what you can spend, and everything else is relatively cheap. I mean, these drivers are between $6 and $13 depending on which one you want. The breakout boards between $6 and $20. Power supply, you're looking at 20 bucks. So when it comes time to the motors, I really would try to get the best bang for your buck for it with the motors. You definitely don't want to go cheap on the motors, otherwise you're going to be disappointed. Now, like I said before, there is gearing and there is other things you can do. You know, putting a belt system on there where you can try to do a reduction. You can get fancy, but again, doesn't change the fact you want to try to keep it as simple as possible. Alright guys, have a good one. I hope it helped.